Welcome to Study Loop.
Now we'll work on problem 84 from chapter 17. In this question, we're asked to write terms for KSP for three different ionic compounds. So first, we'll start with calcium carbonate. So this is a solid which can have an equilibrium with its ions in solution, calcium 2 plus, and carbonate CO3 2 minus, aqueous. So if we're going to write a term for KSP, we can write the ice table, not taking into account the solid, no initial concentration of the ions, plus S for the change, and then S for each equilibrium. So this is a 1-to-1 ratio, so there's no coefficients, stoichiometric coefficients. So KSP is simply equal to S squared. So we can move on to part B now, where we have lead chloride, PbCl2. This is a solid and could potentially dissolve to form lead 2 plus aqueous and Cl, 2 Cls minus aqueous. So we draw our ice table, disregard the solid, plus S for lead and plus 2S for chlorine, and then S and 2S for the equilibrium. So KSP here would be equal to S and then 2S squared, because we're looking at the concentration of lead 2 plus times the concentration of Cl minus squared. So this is equal to 4S cubed. For part C, we have silver iodide, which is a solid and can dissolve in water to form silver plus, aqueous, and iodide minus, I minus. So once again, we draw our ice table. We have a 1-to-1 ratio here, so the changes are simply S. And so we write KSP is equal to the concentration of silver times the concentration of iodide, and that is equal to S squared.